David Smith here with one more flipped classroom math lesson. 3 tips. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with your notes or jot down some questions. Third, you can turn on the captions and read my words on the screen. In this lesson, we're going to look at something called the natural log or natural logarithms. So let's take a look at a few definitional pieces before we get into some math. So these are basically base E logs. That's all that is. So we could write that as log base 278, 18, 28, so on of x. That's a base E log. But we have notation for E, so we can just write log E of x. That's the same as that, log E of x. But since this is a really useful, commonly referred to log, we have a special thing for it. We have ln x, and that stands for the natural log of x. That stands for log base E of x. Now this is so common that you may have already noticed that your calculator, typically if it's a scientific calculator or a graphing calculator, it has a button that's just ln, and that's the natural log. Just like the log button is a base 10 log, the ln button is a base E log, or the natural log. Okay, let's do some non-calculator natural log simplification problems. So here's our first one, the natural log of E squared. So there's a little bit more packed in here now that we don't have log base E of E squared. So this is just ln E squared. So see what you can do. Try to evaluate that, see if you can get it all the way down to something. So here's one way to do this one. I'm going to bring my power out in front. So now I have 2 times the natural log of E. And now I'm just recognizing what this means. The natural log of is log base E. So I have 2 times log base E of E. So this is saying what power do you got to raise E to get E? That's 1. So this is 1 times 2 is 2. Okay, here's a different one. E raised to the natural log of 5. So pause the video, see what you can do with that, see if you can simplify it all the way on down. This one's kind of interesting. So ln 5 means log E of 5. So what this is really saying is what power of E makes 5? So this is the power of E that makes 5. So if we're raising E to the power of E that makes 5, then the whole thing is just 5. Okay, let's try this one. So we have a quotient inside our natural log, so that might give you a clue as to which rule we can use first. Go ahead and take a look at that and see what you get. Okay, hopefully you didn't find this one too tricky. So we have a quotient in here, so we can just subtract the natural log of the bottom from the natural log of the top. So that's what I've done here. Then I use that power-ish rule we have, where I can bring my exponent down in front of my natural log. So I did that for both these terms. Now I have to take a look. The natural log of E is saying what power of E makes E. That's just 1. E to the 1 is E. So both of these are 1. So this is just x minus y. Let's do another simplification problem. This one is even a little bit more tricky, I think. So here we go. We've got E to the x times the natural log of A. So pause the video and see what you can do with that. Play around with it and see what you can find. Okay, here's a first step. This little expression up here, I have x times the natural log of A, so I can take my x and make it the exponent of the term here. So now I have E to the natural log of A to the x. So see if you could take that another step. Okay, I broke it into this step. If you understand what this one is asking, you probably don't need to go to that step, but I want to do that just to make it really clear what's happening. So ln stands for log base E. So what we've got here is log base E of A to the x. So what this is this is the expression. This gives you the power you must raise E to get A to the x. So if this is that power, it's raising E to it. So our answer is A to the x. All right, so let's take a look at some log equations where the variable is inside the natural log and we have to find out what it is. So I think the key to this is being able to rewrite this as an exponential function, and then it becomes super easy. So first off, just for simplicity's sake, I'm going to break this out and go log base e of x equals 3.6. Now, if you remember how to rewrite that as an exponential equation, this means e to the 3.6 equals x. Now, we can do that on our calculator. So go ahead and pause your video and do that and come back. So when I do that, I get 36.6. Now, part of the thing here and where we're going in this lesson is that some calculators don't have any other base logs than the natural log and the base 10 log. So we're going to learn some tricks in a minute for how to convert a log into a log that you can put on your calculator. So let's do another one of these. All right, so getting a little bit more abstract, the natural log of this expression, x minus 1, equals 8.61. So we need to find out what x is. So I want you to pause the video, look back at the last one. The steps are pretty much the same, different numbers, and a little bit of different algebra, but pretty much the same process. Pause the video, see if you can do this one. All right, so the key to this is to convert the log expression into an exponential expression. So this is saying that e to the 8.61 equals x minus 1. Now again, I can pull out my calculator, do that math, and then add 1 to it, and I get 5490. Now, if you look on your calculator, you're going to see that it's not 90, it's like 86, 87, but 3 sig figs, what the IB requires, means that we have to round this to 5490. I want to show you an interesting property of logs, and we're going to exploit that trick in a way that lets you use any calculator to evaluate logs with any base, not just base 10 or base e. So check this out. So if I have a log of base a of x, so that could be any number. In fact, it has to be a positive number. So log base a of x, we can express that differently. We can say log base b of x over log base b of a. So here's the thing, is this base can be any base we want, as long as it's the same. So obviously, we're going to choose bases that we like that we can use on our calculator, namely base 10 and base e. So this is called the change of base rule. So here we are. We have a log base a of x. Now here's the 2 changes that we're going to do. We can use either one. We can make that into log base 10 of x over log base 10 of a. I didn't write the 10 because our convention is we can just write log if it's a base 10 log. So I'm just using this. In this case, my b is 10. So I have a base 10 log. So I can turn this one with weirdo, whatever base that is, into log a, or log 10 of x over log 10 of a. Now, if I don't want to use base 10 as my log, I can use a base e log. So I can also convert it to ln x over ln a. Okay, so this is the natural log of x, or log base e of x, over log base e of a. So logs with the same base. So we're just following this convention, but it ends up giving us a handy trick for using a calculator that won't do alternate base logs. So let's do a few of those problems and see how they work out. Okay, here's one that you can't do on a standard calculator. So when you do these, I want you not to go into the more fancy log function with the base. I want you just to do a base 10 log or a base e log. So first off, let's do this with a base 10 log. So what we're going to get is just going to be log 20 over log 3. And when you put that in your calculator, you're going to get 2.7. Let me check. It's 2.73, like that. So now without an additional prompt from me, I want you to do the same thing, but do it with the natural log. So you look up at your notes there, and then do a natural log, then apply your calculator, and make sure you can get to 2.73. So indeed, I did. I just did natural log of 20 over natural log of 3, and I get 2.73. Now here's the interesting bit, is that log 10 of 20 is not the same as the natural log of 20. So the tops and the bottoms aren't the same, but they're in the same ratio. So when you divide the top by the bottom, you're going to wind up with 2.73 every time. So this is a pretty handy rule. Let me give you a little hint. Here's the rule we got from the last one, the general rule, where we can take, if we have log base a of x, we can insert any base and we put the x on the top and the a on the bottom. So what you can do is you can express this in a way that incorporates these two log expressions. So think for a minute. Remember, these two bases are the same. So we can put them in this position and then put our p's and q's there. So give that a try. Okay, so I'm just using this rule here. And so what I'm doing is I'm picking 4 as my base because that's my target. I need logs of base 4. And I can get both of them into log base 4, so that's cool. So I'm doing log base 4 of 9 for the top and log base 4 of 7 for the bottom. So now I have this expression that I can then figure out how to do my substitution because I have the 9 on top, and that's Q, and I have the 7 on the bottom, and that's P. So this becomes Q over P. So that's the expression of log base 7 of 9 in terms of Q and P with this substitution on the top. Now that you've watched the video, take a moment to jot down some notes, some questions, or a quick summary of the content. You can also re-watch the portions of the video that were a little bit challenging. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.